Hello everyone, welcome back to another video from Winter Forest. Today let's continue our leetcode challenge. Today's question is called the longest duplicate substring. Let's look up the question. Given a string S, consider all duplicate substring. Substring of S that occur 2 or more times. Their occurrences may overlap. Return any duplicate substring that has the longest possible length. If S does not have a duplicate substring, the answer is empty string. Look at the first example called banana. It is ANA because the ANA and the ANA duplicated. Look at the second example is ABCD. They are Unicode characters, so the result is empty string. He tells the length is from 2 to 10 times 5 power over 5. And S considered a lowercase English letter. So only search for 26 characters. For string research, they have 3 popular algorithms. One is called the Rabin-Karp algorithm. Another one called the KMP algorithm. These two actually suitable for single pattern research, but in our case, they didn't give you fixed pattern. We're going to find the longest duplicate string, so it's actually going to do multi-pattern research. So it's exactly the case in here. So what is the Rabin-Karp algorithm? Yeah, you could look in here, find the theory. Basically, it actually just convert a character a two-digit number, and then you compare this number. It is you like the 4 ABI in a string. You find it, then you go into character, find another 4 again. It means they are duplicated. Let's look use the banana as an example in here. I try my best to explain. I hope I could make you understand it, but actually this is not a simple question. So if we have a banana, the hash map you actually could be different. So for example, I assume A equal to 1, B equal to 2, and C equal to 3. I will change this to D equal to 4, and so on. N actually is 14. So we're going to use the binary search. First, cut this to half. It actually is 3. So if we could find 3 character could already duplicated, we found it. Then we don't search for 2, so we cut this half. It is 3, so the length is 3. We're going to find 3 duplicate in here exist or not. Yeah. We're going to use slide window. We start the left, so actually it is this one, BAN. So we're going to hash BAN. What is the hash value for this one? The B is 2, the A is 1, the M it is 14. So this it is 17. The hash value for this one. Then we move the window to here. We drop the B and add 1. So the hash value, it actually is A and A. So in here, it actually is 1 plus 14 and plus 1. So it is 16. And we haven't found the duplicate over there yet. Then we continue move on. We're going to drop the A again and move to this NAN. So now we find the hash value NAN. And the NAN actually it is 14 plus 1, then plus 14, then 28, 29. And then we start continue another one. We drop the N and add 1. It is this one. So the hash value going to find is ANA equal to 1 plus 14, then plus 1. It is 16. 16 did I see before? Yes, I already see before. So actually this is the answer. And this is because you just cut one half, the found you could be potential cut it is 4, didn't found it, then you're going to cut again. If this is if you cut this founded, then you are even you found this is found, you actually add one more if you could find the or not. If you can't find it, then just you move the point. That is what we are going to do. So just let's write the code. So we're going to have the names, and then for the string the names. So we're going to, and then the first thing I'm going to convert the string to array of integer. So we could implement a constant time slice. So you have a int numbers new int in. So the names is the string names, the integer of names names, array names names. Then we have the for loop. We update the value to this character value. We're going to change string the character at this I and minus this one, because the character have in the Java they have a digit number represented. String at the character I and convert the int and the minus equal to this one. Yeah. Now we're going to do search, and we need to have the base value for this one. And the base value is 256. The model value is 101. We're going to use the, you see here, he could be a biggest number, so we're going to use the biggest model number. So let's start it. So in the base value, I only use 26 because he said only consider lowercase English letter only have a 26 character. And but then model value we just use longer. Just use what? 2 and 32. And now we're going to do binary search, and left start one, at least there are 2 characters, so left equal to 1, right it is the last, right equal to n, the last character in the, and the names going to the L. I didn't edit it, so when you do the binary search, the L via the middle, so you're going to have the while loop. The left not equal to the right, then you're going to search. So the L is actually and equal to the left plus. So this binary search, this is a pattern. You need to remember if you did some. I don't think you could remember it. So if you find it, we're going to have a help function. We call it like a search. If you search, you find it. How you search, you go into are looking for names L and have the base value A and have the model value and have the names of this string is M and the numbers and they represent the character. If you find it, if this node equal to -1, it means you found it. Then the left equal to L plus 1. You're going to add one more character C if this also, if you cut too small means. And else is cut too big, then the right move to the L. This help function. we're going to return integer search. We have the name, we're looking for the names, and we have the base value A, we have the known value is our model, and we also have the number of the character, the names, and we have the array of these numbers represent the character. And here we're going to finish, but before I finish this first, if you after you finish you have the L, you already know the names is this one, but you actually don't have the started value, and the started value actually you could use this search help for function going to left -1, and then the base value and this model value, and actually this could define like a static, then don't need a password. Never mind, just put in here n, then it is the names. 1, 2, 4. And if you find that they started, then just return start not equal to -1. So you actually string substring the start plus left -1. This is the substring. And if you didn't find the return empty, now we just rewrite this search. This search actually just the Rabin-Karp algorithm. So what are we going to do? And just we have the we compute the hash of the string value. So if the hash value by default is 0, now we're going to compute it. And the hash value equal to the hash value times the base value, and you plus this value number of I, and you model the model. And if we also, because do a search in this array and names I, so we're going to have a hash set, make sure we don't duplicate the search, hash set no. If we already seen, so in the new hash by default dot add h. Now we're going to convert the value to used often. So we're going to write it the known al go to 1, and then the for loop. The base value and model, the model. And we're also going to search search. we're going to learning the hash. Keep learning the hash. Okay. H equal to H times A minus start minus 1. We need a times AL, and we need a model. The mod, and we add model. Now we're going to model. H First, we check if it contains this before. Then we just return. If didn't, then we just add it. If we looping finish it, didn't return, that means didn't find, then return -1. Okay, let's run the code and see if I have a syntax issue. Action is not equal to 43. 43. Yeah, 44. Then, yeah, because this is not 44. Okay, 17. We have this start. We start with the 1 because the list has 2 characters, and we use the start on the length -1 plus, and the start. What did they say? The model 70. Next one, and the h equal to h times the base value minus h minus start -1, so I get the value start -1. Sorry, I defined another one, the AL, because you don't know how this is also the next segment you're going to find it. So you're going to, it is AL, then you're going to model it. After the model, you're actually also going to add the value. Then you're going to model it, and you're going to add the previous ones, the L -1. Yeah, let's submit and code. Return. Okay. Return action. This is so if start not equal to 1, so you found it, means you found it. So the substring, the start plus left -1. Yep. Okay. Yeah, it's done. It found the NA. Let's submit it. Yeah, it accepted. Just let's recap it. This is actually quite a difficult question. What we actually did, we actually just do the binary search the names of longest duplicate the substring, and we called the help function search. And the search action like working as a slide window of names L. Now the hashed string in this window, we called the same string in the hash and try to find the duplicate string. And here we give a big model for learning hash, and it should be enough for this problem. Actually, there could be a hash coordinate. One solution is to have two different models for hash, or we use a hash map to record this index of string. And now let's look up, once this finish, let's look up the time complexity. Actually, for binary search, in here for binary search, the time complexity is O log m. But for the learning hash, we actually is O(n). The overall, so together, the time complexity is O(n) log m. The specific complexity is O(n). We only allocate each one, only have one. So hope you find this helpful. Actually, this is quite a difficult question. I'm not sure you fully understand it, but the way it actually is used this to achieve it. If you didn't understand, I just go here, have a look up the description, and also search somebody explained very well about this algorithm. Thank you for watching. Hope you found this helpful. Bye.